The Voyager 1 spacecraft of NASA presently holds the distinction of being the most distant human-made object from Earth. It has captivated people all over the world for nearly 50 years. Since its launch, Voyager 1 has relayed crucial information from the farthest reaches of space, enhancing our comprehension of the cosmos. Recently, however, the transmissions have displayed peculiar irregularities that have puzzled scientists. These enigmatic signals have sparked heated debate, prompting the scientific community to determine if these anomalies are the result of mechanical failures or hint at something far more remarkable, perhaps even of extraterrestrial origin. Join us as we investigate these perplexing communications and explore what may be hidden in the infinite expanse of space. The fundamental yearning of humanity to unravel mysteries has long fueled the search for space exploration. This profound curiosity accelerated significant endeavors like Pioneers 10 and 11, two of the most daring investigations of their era. The launch took place on August 20, 1977, from NASA's Kennedy Space Center. Voyager launched a groundbreaking epic in cosmological research. Shortly thereafter, Voyager 1 was launched on September 5, 1977, embarking on a journey that would bring it significantly closer to the other planets, modifying both its course and scientific objectives. Each probe, weighing roughly 721 kilograms, similar to a small family car, traveled in divergent directions at distinct velocities. By December 15, 1977, Voyager 1 had outperformed its companion in terms of distance covered due to their separate courses. Since then, Voyager 1 has been crucial in enhancing our spatial perception, presenting findings that have changed our perspective on the universe. Before diving deeper into its recent shocking revelations, let's look back at some of its earlier landmark triumphs. In 1979, approximately 265 million kilometers from Earth, Voyager 1 captured high-resolution images of Jupiter. That year, in January, it completed an impressive 100-hour surveillance, resulting in a time-lapse sequence illustrating Jupiter's rotation. A group of 3,750 images provided unparalleled insight into the planet's turbulent atmosphere and intricate structures. During the same trip, Voyager 1 discovered a previously unknown ring around Jupiter and two previously undiscovered moons, profoundly enriching our understanding of the gas giant's intricate system. To maintain its proper course and avoid a possible collision with one of Saturn's moons, Titan, the spacecraft carried out multiple trajectory adjustments. The mission then shifted its focus to look beyond the solar system's planets, sending the vehicle into interstellar space at an incredible rate of 325 million kilometers annually. In 1990, Voyager 1 began its mission to probe interstellar space, venturing beyond the solar system's boundaries. During this stage, it accomplished several extraordinary milestones, such as the discovery of Mimas, Enceladus, and for other new moons Rhea, Tethys, and others, while acquiring some of the most iconic images from the solar system's most remote regions. On February 14, 1990, from nearly 6 billion kilometers from the Sun, Voyager 1 captured the legendary family portrait, a panoramic mosaic of the inner planets. This assemblage of 60 photographs became part of the extensive image repository that already contained hundreds of pictures taken during its encounters with the massive planets in close proximity. Voyager also recorded impressive accomplishments in its own right. It measured wind speeds on Neptune exceeding 2,100 kilometers per hour, roughly 1,300 meters per second, the fastest atmospheric flows ever noted within our solar system. It also observed Triton, Neptune's largest moon, where surface temperatures fell to a chilly -391 degrees Fahrenheit, -235 degrees Celsius, making it one of the coldest places known. Triton displayed indications of cryovolcanism, which releases nitrogen gas and frozen particles as high as 5 kilometers, revealing fascinating information about its geological dynamics. These groundbreaking findings significantly increased our understanding of the numerous and dynamic conditions present in our solar system's outermost regions. Voyager 1's and Voyager 2's influence was completely transformative. Their findings revealed Jupiter's previously unseen features and the moons of Saturn, once thought to be geologically inactive. These brand new insights revolutionized prevalent theories regarding their geological activity. Voyager 2, in particular, cemented its place as the only spacecraft in history to fly by Uranus and Neptune, a singular achievement. NASA introduced novel strategies to extend the mission's duration, including shutting off non-essential systems to conserve power. This campaign is expected to continue until the year 2030, marking the conclusion of an extraordinary mission spanning decades. Voyager 1's and Voyager 2's engineering and design showcased cutting-edge technology. Built to rotate slowly, the probes minimized motion blur in their imagery during flight. Prior to reaching the outer planets, the spacecraft began providing high-quality images of Jupiter's swirling storm systems, including the well-known Great Red Spot, a massive vortex that has enthralled scientific interest for years. One of the most striking discoveries was the discovery of Io's active volcanoes, one of Jupiter's moons. Onboard instruments registered anomalous data, later confirmed by visuals depicting enormous volcanic eruptions and newly established terrain on Io. One of these eruptions was thought to be 1,000 times stronger than Mount St. Helens explosion, nearly covering an area equivalent to the size of France. As both probes advanced in their missions, they gradually turned off different systems to maintain power and prepare for entry into interstellar territory. Notably, they did not take photographs of Mercury or Mars due to equipment constraints. NASA later began additional significant investigations like Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Voyager 1 surpassed Pioneer 10 and became the most distant spacecraft. Still, Voyager 1 continued for another 14 years before officially crossing into interstellar space on August 25, 2012. A pivotal factor in the mission's triumph was the tactical use of gravitational assists, leveraging planetary gravity to gain velocity and alter trajectory while conserving fuel. Rather than depending solely on onboard propulsion, the probes exploited gravitational slingshots to traverse vast distances effectively. As Voyager 1 approached Jupiter, the planet's enormous gravitational field sped up the spacecraft. Precise calculations were necessary to prevent dangerous changes in speed or path. These gravitational maneuvers enabled both probes to navigate the solar system with incredible proficiency. Voyager 2 likewise harnessed gravitational momentum from Jupiter, Saturn, and Uranus to plot a course toward Neptune, further confirming this navigational strategy. Reflecting on these enormous expeditions, the scientific community is excited about deciphering the most recent abnormal emissions from Voyager 1. These inquiries persist. Operation that goes far beyond the norm, the solar system's boundaries, which continue in trying to solve the mysteries of gas giants like Jupiter and Saturn, Neptune, and Uranus. The Voyager 1 vividly documented time-lapse sequences 10 Jupiter eruptions that revealed new satellites discovered in addition to an invisible ring that surrounds the planet. These revelations significantly enhanced our comprehension of the Jovian system. Similarly, Voyager 1 discovered for brand new moons of Mimes, Enceladus, and Saturn Tethys and Rhea, while also transmitting stunning images of Saturn and the ring around its system, revealing their in-depth architecture. The flybys of the mission of Uranus and Neptune delivered pivotal information regarding their atmospheres and moons, enhancing our understanding of the remote regions of the solar systems. After completing their flybys of the planets, the trajectories of the two vessels began towards space between stars, where they continue to send important scientific data. The current expedition increases our understanding of what lies beyond our planetary neighborhood, as the world awaits new discoveries from the unusual transmissions of Voyager 1 and their possible implications for cosmic science, these pioneering endeavors keep stimulating researchers and worldwide space enthusiasts. Their achievements continue to be fundamental in advancing human insight and pushing the limits of astrophysical inquiry. The Voyager projects have provided unmatched perspectives of our solar system, revealing iconic imagery and important research findings. Outside of their technical accomplishments, the probes additionally transport a symbolic object, a greetings from the Earth to anyone intelligent otherworldly civilizations. The legendary record includes greetings in 55 languages, musical selections from diverse cultures, and recordings of the background like the sounds of whales and thunderstorms. This interstellar message serves as the optimistic greeting of humanity to other intelligent individuals, both Voyager 1 and 2 outfitted with a suite of scientific instruments that significantly expanded our comprehension of space. These included sensors for the magnetic field, imaging, and plasma wave detector systems, each of which offered vital data about the space environment. The magnetic was decoded by magnetometers, fields of the planets further out, illustrating how these fields interact with their surroundings. Wave of plasma detectors disclosed how solar wind influences atmospheric layers. One of the mission's highlights was charting the boundary of the heliosphere, a vast area populated by solar particles and electromagnetic fields that surround the solar system. As Voyager 1 got closer to this boundary, it observed a shift from solar wind to interstellar matter, offering crucial insights into the protective Earth is protected from high energy by bubble cosmic particles. The craft in space identified a region that is known as shock at the end, where solar winds decelerate and compress. Besides this resides the turbulent heliosheath, where materials from space and spacetime meet converge, forming a volatile cosmic environment. The journey of Voyager 2 also significantly improved our comprehension of the solar system beyond Earth. It's close, the results of flybys of the massive planet's vital discoveries, especially regarding Uranus's magnetic field, which was found to be tilted and offset in ways that contradicted theoretical predictions. The result of these observations has been continued research into planetary magnetism beyond their scholarly contributions, and the missions of Voyager rekindled public fascination with space exploration. The hypnotic images of worlds far away and the captivating story of the missions that have motivated generations. Dramatic images such as Jupiter's rings and the glowing ones on Saturn moons that explode have become a symbol, evoking the fantasies of the future explorers and scientists. As Voyager continues to transmit extraordinary data, its extended passage through space between stars provides rare chances to decipher the mysteries of the universe. While earlier missions primarily focused on planets, venturing into interstellar realms has unveiled unexpected complexities. Regions once presumed empty now exhibit complex phenomena that pose a challenge current approaches to science. One of the most fascinating results is the detection of the origin of cosmic rays from a galaxy other than our own. These extremely energized particles traveling near light speed provide clues concerning activity in distant star formation regions and galactic phenomena. By analyzing their makeup and intensity, scientists aim to decode the behavior of galactic and remote stellar nurseries processes. In addition, as Voyager 1 and 2 venture further into interstellar space terrain, their scientific sensors keep looking over the writing and motion of matter between stars. The sparse gas and dust situated between stars. The material in question interacts solar wind and the way it shapes the heliosphere. As the probes traverse these areas where crucial data is transmitted that assists scientists in modeling how energy and matter behave throughout the universe. Additionally, Voyager missions have shed light on the structure and influence of magnetic interstellar space fields, displaying their arrangement throughout the galaxy. These revelations could eventually lead to profound breakthroughs in our understanding of forces of magnetism in the galaxy. The ongoing endeavor to investigate these far-flung regions not only adds to our understanding of science, but also motivates subsequent generations of aerospace engineers and astronomers. The unforgettable images captured by Voyager, specifically the well-known pale blue at showing Earth from over 6 billion kilometers away, serve as a moving testament to our tiny existence within the vast universe. These visuals, taken together with the mission's scientific successes, have fundamentally altered our methods to comprehend our world and its position in the universe. The victorious Voyager missions has paved the way for even more ambitious endeavors thanks to realized technological advancements launching during their operation. Advanced spacecraft to the galaxy's outer regions reaches is expanding at an alarming rate. Feasible goals like exploring potential discoveries from exoplanets, worlds that are habitable, and even interstellar expeditions are steadily changing from daring goals into achievable goals for the upcoming era of exploration of space.